The purpose of today's video is to transition us from Chapter 7, in which we learned about ionic bonds, to Chapter 8, in which we are going to learn about covalent bonds. Chapter 8 has two main goals. Our first goal is to be able to look at a molecular formula and figure out what information it gives us. Our second goal is to be able to describe molecular compounds and ionic compounds in their simplest form, which is called a unit. Down below, you can see some terms in orange. These terms will be our vocabulary terms for 8.1, so please pay special attention when you see them in the video, as they will be important for all of Chapter 8 and future chapters. Now, before I introduce new material, I want to briefly recap what we learned in Chapter 7. In Chapter 7, we learned about how ionic bonds are formed when a valence electron moves from one atom, such as a sodium atom, to another atom, such as a chloride atom. This transfer forms a new compound called sodium chloride. Sodium chloride, as you know, is table salt, and at room temperature it exists as a crystalline solid. This is common for ionic compounds, as you'll remember from Chapter 7. But there are many kinds of compounds. For example, nitrous oxide is a compound that's commonly used at the dentist, and it's a gas. Water is a common compound that's all around us, but it's a liquid. So what makes these different? Actually, it's going to be the fact that there are not ionic bonds. Instead, there are covalent bonds. That electron is not transferred from one atom to another, but instead, each atom has their own electron, or bone, which are then shared in a tug-of-war type experience. This is called a covalent bond. If there is a covalent bond, then we can call it a molecule. So here are two different kinds of molecules. Oxygen, the air that we breathe around us, actually doesn't exist as singular atoms. Instead, there are two oxygen atoms together, joined by a covalent bond, that exist as an oxygen molecule. We can find this out from our molecular formula. So the molecular formula actually tells us how many atoms are there. There are two oxygens. This can be called a diatomic molecule. Di is a Greek word that means two, so it can tell us that there's two oxygens. Water is another example of a molecule, and here we have two hydrogens and one oxygen. So here we can also look at these two molecules and notice that they have a different feel to them. This one has the best friends forever feel, and this one has the pooling sensation. We're going to learn about how molecules can be different later on in Chapter 8. Here are some more examples of molecules. A caffeine molecule has, again, how many of each atom? 8 carbons, and so on. Now, it's important to notice that these are all divisible by 2, but they're not reduced. Ionic compounds are reduced to their simplest form, but that's because they don't actually function as a unit. But when there's a covalent bond, it does function as a unit, and the molecule only exists in this form. It wouldn't exist in 4 carbons, 5 hydrogens, 2 nitrogens, and 1 oxygen. That is not what makes caffeine. So that's important to notice, that it's always going to tell you exactly how many atoms make up that molecule. Here's our last example of a molecule, ammonia. We have 1 nitrogen and 3 hydrogens. We can get that from the molecular formula. What we can't get from the molecular formula is what it looks like. So we have other formulas, models, and drawings that can help us with that, and we'll learn more about those later on. Now, for the last part of our video, we're going to address the second objective, which is to be able to describe molecular compounds and ionic compounds. So for this part, I would like you to go to page 224 and 225 in your book. There, you can find more information about these phrases. What I would like you to do is to draw in your notebook a Venn diagram and to sort these phrases. Which ones to describe a molecular compound? Which ones describe an ionic compound? And which ones describe both? So at this point, you can pause your video and you can go ahead and sort these words. Great! Now that you've done that, you can check your answers. If you have any questions about these, I'll set aside a few minutes at the beginning of our next class to talk about it. We've now reached the end of our video, and we now know what information we can get from a molecular formula. We can find out how many of each kind of atom are in the molecule. Also, we can describe molecular compounds and ionic compounds.